So let's try more example. How do you arrange your design of experiment using the linear graph? I already show you one example. Here, A, B, C, D, all right? And we want to analyze the interaction AD and BD. This is the example I should show you. And you can see this is one of the possible arrangement, which makes sure these two interactions can be estimated. How about the other example? Now you still have 1, 2, 3, 4, 4 two-level factors, A, B, C, D. But now you need to analyze 3 interactions. See, AD, CD, and also BD. Previous example, you only need to worry about 2 interactions. Now you need to worry 3 interactions. How do you assign these factors to your orthogonal array? First, there are 2 linear graphs in L8. You know L8 is good because there are only 4 two-level factors. We can start from L8. But is L8 okay? Okay, right? We have 2 linear graphs. First, we want to double check if this linear graph is okay. From the problem, you know we need to analyze AD, CD, and BD. So which one appear the most? 哪一个因子出现最多次？在交互作用里面出现最多次 ？Which factors appear the most in the interaction factors? In the interaction effects? D, yes. So we assign D first. Before that, let's look at the interaction. We need to put D in some place in such a way, you see AD, CD, BD. In such a way, D will have 3 lines connected to a certain dot. Because we need to analyze 3 interactions, all related to factor D. From these 2 linear graphs, you can see this one is better, right? This one is more suitable because this linear graph will have 1 dot, which has 3 lines connect to a certain dot. Unlike first linear graph. In the first linear graph, only 2 lines connected to 1 dot. If you assign your factors D to any of the dots in the first linear graph, you will find out that you can only measure 2 interactions with factor D can be assigned. The number 3 interaction, no place to fit. So you need to select the second linear graph. From here, number D should be assigned first. Assign D to a dot to a linear graph with 3 outreaching lines, which number 2 linear graph is suitable. So we assign D to factor 1. So we assign factor D to column 1. Then we know what will be the second factor to assign. We look at from the interactions. They are factor A, C, D in the interaction. Let's assign factor A first. We put it in column 2 because column 2 will connect it to factor D. So we make sure the interaction between AD can be estimated. Same thing. The next one is B. We'll put it in column 4. Same thing. C, put it in column 7. So the interaction AD, CD, and BD, they all connected to this dot number 1. Make sure AD can be analyzed. They reserve column 3 for AD, column 5 for BD, and column 6 for CD. Therefore, A, B, C, D, and all 3 interactions can be estimated without worrying that these 4 factors and 3 interactions will combine with each other. Next, let's try to arrange the design for 3-level factors. The question tells us that we have 6 three-level factors, A, B, C, D, E, F. And also we have 3 important interactions. Here, AD, BD, and AB. Now we want to assign this design to an orthogonal array. That's from the selection of orthogonal array table, right? Remember, we double check. We need to find the design to fit 6 three-level factors, and let's go into the columns. And this example, as I mentioned, this is different arrangement. Right? In this problem, we have 3-level, 6 factors, 6 three-level factors. We need to analyze 6 three-level factors and 3 interactions. This is the question tell us to do. So we first look at the standard orthogonal array, and we know we need to analyze we need to find the orthogonal array can be used for 3-level factors. So let's look at this one. And look down, we know that the L9 is L9 okay? L9 can only be good for 4 factors, but now we have 6 3-level factors. So L9 too small. How about L18? L18 looks okay, right? Because it can accommodate 7 columns. But remember, can we select L18? Can we select L18? There are 2 reasons that we cannot select L18. Well, you see L18 can accommodate 7 3-level factors, and we only have 6. Why not? Why can I select L18? 2 reasons. First, okay, Wei Qiao said that it may not be big enough for the interaction, since we need to consider 3 more interactions. So it may not be big enough. Okay, this is one of the reasons. But the most important reason is I show you there are 2 special orthogonal array. Why they are special? Yeah, L12 and L18. Remember, I told you that L12 and L18, they cannot analyze interaction because it is a special orthogonal array, and they kind of distributed all the interaction to the rest of the columns. So you cannot use this orthogonal array to analyze the interaction. But in our questions, in our problems, I ask you to analyze A, B, C, D, E, F, and also these 3 interactions. Therefore, L18 pass. You cannot use L18. What's next? Go to next one will be L27. Well, that's why L27 show up in these questions. So we should select L27 in this example, since we want to analyze 6 3-level factors and also 3 interactions. There is a linear graph over here for L27. As I see, there are 2 linear graphs, 1 and 2, 2 standard linear graphs. Which one should we select? Well, let's look at the problems. We have 6 factors. So can we select linear graph number 2? Okay, yes, it has to have 2 lines connected to, say, D. And this is only have 1 line. But the most important thing is what? 大风吹什么？吹没有戴眼镜的人，所以最后坐下来以后发现怎么样？少一个位置。我们现在几个因子 ？How many factors do we have? 6. We have 6 factors. How many dots in linear graph number 2? only 5. 大风吹，位置不够啊。Yeah, so there are only 5 dots. No way you can assign 6 factors. All right. The other student said that you cannot find a dot connected to 2 lines. D connected to 2 lines, but you also need to another dot B connected to line. Yes, that's another reason. But the most obvious reason is there are not enough seats. There are only 5 dots for 6 factors, too small. Therefore, linear graph 1, 1, 2, 3, 4, 5, 6, 7. 7 dots. Good. At least it has enough seats for all the 7, for all the 6 factors. All right. So from this reason, we get rid of number 2. We can only try number 1. And let's double check is from number 1, they have enough seats, but how to assign the factors? And go to the second principle I just mentioned. We assign the factors in the interaction first. And also, especially for those appear the most. We see D appear 2 times, B appear 2 times, A appear 2 times too. So we need to take care of A, D, and B. The linear graph has to have 3 dots. Those 3 dots all have 2 lines, right? So look at the first linear graph. This is good because they have 3 dots. Each dot have 2 lines. Can satisfy the requirement I just introduced for, for this problem. Okay. So how to start it first? Let's start from these 3 factors, A, D, and B. Let's start from ABD. But we need to select this linear graph. Start from A and put it in column 1. You can put it in some other dot, column 2. They will be okay, but I put it in column 1. And then what's next? And this column 1 is okay, since column 1 have 2 lines. And in this problem, we said that the A need to put it in some place, have 2 lines. Why? Since you need to consider AD, and also we need to consider AB. So A need to put in a dot with 2 lines. Same. Next one, let's put B. B is another factors happening in the interaction, need to have 2 lines. Since we need to consider BD and also AB. Same thing for factor D. After we put it in ABD, then we need to we can be very happy the interaction AD as reserved in column 6 and 7. See, 2 columns. Same thing. AB, 2 columns. 3, 4. Same thing. BD. What else? We already assigned 3 factors. We still have 3 more factors to assign. ABD, okay. Then C, E, F. How can we assign factor C and F? Simple. Any place with a seat, and the seat is empty. Because C, E, F has no interactions. Therefore, any seat will be okay. Unlike A, B, D, they are picky. They need to have a seat with 2 lines due to the interaction, due to the consideration of the interaction. So for the rest of the 3 factors, let's put C in column 9 because column 9 is empty. Same thing, column 10 and column 12. Any questions? Any questions? Okay. Try another example. So far, we are pretty lucky since we can only find the linear graph which is suitable for our problem. So we can put all the main effects and also all the interactions in a empty columns. Let's try example number 4. The same, we still have 4 two-level factors. Make sure the problem. 2-level factors, 4 two-level factors, like the previous example. But now you need to consider AD, AC, and BD. 3 interactions, very similar to our previous example. 3 interactions. But the interaction combination is a little bit different. You see, AD, AC, BD. Let's start from L8. And try to assign that. Let's see, although in L8, in this example, linear graph has 4 dots, 3 lines. Theoretically, it is good for a design with 4 two-level factors and 3 interactions. But let's try to do that. And you'll find out that no matter how you arrange your design, you cannot make sure all 3 interactions can be estimated. Why? Let's try this first arrangement. You can look at a problem and you probably will know why already. We need to find for here AD, AC, and BC. So we know A happened twice, D happened twice, C and B only happened 1 time. So we need to assign factor A and factor D first. We know that factor A need to have a place, have 2 lines. Same thing. Factor D also need to have a place for 2 lines, right? So this is one of the possible arrangement. Let's put A in column 2, D in column 1. Therefore, luckily, we know AD can be estimated, right? AD can be estimated. And as you can see, next one, you can put B over here. Since we know the next one, we need to put factor already AD, right? Next, we need to assign B and C. Let's start from B because BD interaction need to be considered. So we put B here. Therefore, BD is good. Have a place to sit in column 5. How about C? Now we need to assign C. Too bad. Only 1 dot left, which is column number 7. So you can only assign C to column number 7. But the problem is you need to consider the interaction between AC, right? You need to consider interaction between AC. But are you sure AC can be estimated? Since you see, there's no line between A and C. There's a line between AB. So if you want to analyze the interaction of AB, which is okay in column 6, but the problem said AB is negligible, right? AB is negligible, but AC is important. However, no line for AC. What happened? What does it mean? No line for AC, which means that the interaction AC cannot be estimated in this arrangement. Why? Let's double check. Let's analyze the confounding structure. This is a confounding structure for this problem. And I assume you all know how to get a confounding structure. And from here, fortunately, AD okay, BD okay, but how about AC? Here, you know, AC and BD are confounded to each other in this kind of arrangement. But AD is okay. AD can be analyzed, although it confound with BC, but BC is negligible. But BD and AC, they confound with each other from this arrangement. Therefore, we cannot separate interaction BD and interaction AC, which means that these two interactions cannot be estimated. They cannot be analyzed, since they confound with each other, which means that if you want to analyze AC, then you need to save column number 5 for AC. However, in this arrangement, we already saved column number 5 for BD. Therefore, AC interaction and BD interaction, they confound with each other. So this arrangement is not good. It cannot make sure you can analyze all these two level factors, and also to make sure all these 3 interactions can be estimated. How do we do? We need to go to a next bigger. As you can see, there's no room, not enough room, or even though there's an empty room over here, but due to the confounding structures, you can try some other arrangement. However, you still cannot make these two separated. They are too stubborn. No matter how you arrange it, some of the two interactions will confound with each other. You cannot separate them. In such a case, L8 is not big enough. We need to go to a next bigger orthogonal array, such as L16. Can we use L12? Since L8 is too small, right? The next bigger orthogonal array is L12. Can we use L12? No. Based on the same reason I just showed you in that example, L12 cannot be used to analyze the interaction. So no L12. Next, L16. Any questions? All right. So by look at you can see the result by look at the interaction table. So if you look at the interaction table, you can find out the confounding structure. So here I just skip the process, but you can see the confounding structure. All right, you can see right here. The confounding structure show you that AC, the interaction AC, which is column 7 and column 5, column 2, sorry, 2, 7. 2, 7 will happen in column 5. Will happen in column 5. Therefore, AC will confound with column 5, which has been occupied by interaction BD already. You can try some other arrangement, but I will make sure you won't be able to fit. You won't be able to fit all 3 interactions. You won't be able to separate all 3 interactions in different different columns. So how do we do? Or in some example, can we modify our linear graph to make sure that our design can be analyzed? Time is up, so I just want to touch a little bit and we can make it up next week. If you want to make sure, if you want to use the linear graph for some design with the anti-interactions, let's give a brief overview that we first need to select appropriate linear graph for our experiments. And we assign the factors to the dot and assign the lines to the interactions. But we need to select carefully, make sure that the lines will be reserved for those important interactions. If our standard linear graph cannot fit, is not suitable, how do we do? One way is go to next bigger experiment. The next way is you can try to see if you can modify this standard linear graph to make sure that all the dots can be assigned to your design, to your orthogonal array. I will show you how to modify your linear graph, but all the modification has to be double checked with the interaction table, has to be consistent with the interaction table for the array. For instance, if you have 2 level factors, 5 2-level factors, and 2 interactions, AD and BD, how to assign 5 factors and 2 interactions? So let's look at the linear graph. Is this linear graph can be used for this problem? Can this linear graph be used for this problem? 可以用吗? Can it be used? Can it be used? No, the same reason, right? Not enough seats. Okay, not enough seats. 4 dots, but 5 factors. How about the next? Is this good enough? 1, 2, 3. I'm sorry. How about the other linear graph? The other linear graph looked like that. I didn't show it here, but the other linear graph looked like that, right? I forgot. This one, right? But other linear graph looked like that. This is not good enough either, since only have the same 4 dots. How do we do? Well, this linear graph doesn't have enough dots. How do we do? Either we go to a next bigger linear graph, bigger orthogonal array, or we can try to adjust it. There are enough seats, but some of the seats reserved for the interaction. But if the interaction is no need, then we can detach the line to make it another seat, another dot for additional factors. Such this way. As I mentioned here, if the interaction between 2 factors is negligible, although the original line is reserved for the interaction for the one in, this is column 1, sorry. This is column 1, I didn't write it here, right? If the interaction between 1, 7 is no need, since we only have 2 interactions, right? If the interaction between 1, 7 is no need, which I need to reserve 2 lines for these 2 interactions, then we can detach the line. See? The line can be detached and to create additional dot. So you can create another linear graph on the right, which can be used for 5 factors and 2 interactions. But the assumption is if some of the interaction between 2 dots, which was a line, but the line is not used, is not occupied, you can assign the line to another dot, can be used for other dot. Okay, any questions? This is how you modify the original linear graph to some other linear graph to fit your design requirement. Once you have this kind of modification, then this problem can be solved. You want to assign 5 2-level factors and 2 interactions. This one is good because D happened twice, so we assign D first to a dot with 2 lines, 1 for A, 1 for B. So here, A, B find their place in column 2 and column 4. Next, we still have C to assign. Then we put C in column 6, E in column 7. Voila, we finish our assignment. And in this assignment, we make sure all these 5 two-level factors can be estimated, and also these 2 interactions, AB, AD, sorry, and BD can be estimated. I'm going to stop here. I believe it should be helpful for you to understand the rest of the section, but I will cover that in next week.